My name is Jessica Johnston. I am the Education Program Coordinator at the ESA, and welcome to our water cooler chat today on active learning, lectures, and student outcomes in 4D. Before we get started, I'm going to just go over some quick housekeeping notes. So if you haven't joined our water cooler chat before, this is an informal conversation that we like to have where we explore each other's ideas and experiences. And it's led by guest hosts. If you'd like to join the conversation, what we ask you to do is to raise your hand. And then when you have your hand raised, your name should bubble up to the top of the participants list, or we'll even see your little raised hand on the screen. At that time, you can unmute your mic, but if you have not been called upon, we please ask you to keep your mics muted. But we also encourage some concurrent conversations in the chat box. So anytime that you have something that comes up, if you don't want to raise your hand, you don't feel like being verbal, you're more than welcome to communicate through the chat box, and we'll try to keep up with all of that. The chat can be buzzing at times, so just bear with us. This is a second reminder that we are, in fact, recording today's event. So if you do not want your video to be shown or your name, you're welcome to change your name and turn off your video. With that being said, it is my honor to introduce our esteemed host, Justin St. Juliana, who is at Cornell University. Justin is a senior lecturer in the Ecology and Evolutionary Biology Department at Cornell. He has his master's degree in evolutionary ecology from Ben Gurion University in Israel, his PhD in biology from Indiana State University. Justin's research lies in the interface of predator-prey interaction, optimal foraging, and stress hormones. And before taking his position at Cornell University, he was an associate professor at Ivy Tech Community College in Indiana. He's taught multiple biological levels from microbiome to environmental science. Currently, he teaches a large mixed majors and non-majors ecology and the environment course at Cornell. And he's very interested in the latest teaching innovations and heavily incorporates active and community-based learning into his courses. He believes scientific concepts can be taught as stories that relate to a student's life. And he extensively utilizes technology to improve student learning outcomes. He's the author of dozens of digital activities and a co-author of the environmental science textbook, The Environment and You. So with that warm welcome, I'm going to kick this over to Justin. He's now in charge, and thank you for joining us, everybody.
All right. Thank you very much for that, Jessica, and I'm happy to be here today, which is to talk about two of my favorite things, active learning and 4D ecology. Today, I'm going to be talking about a lot of things I've done, but this has been in conjunction with a teaching team from over the years and multiple semesters. And so, while I'm presenting today, this is very much a team effort across time. So I do have some learning objectives for our discussion. And I hope by the end of our discussion today, you'll understand an example of the development and implementation of active learning with 4D in lectures. Think about active learning in 4D in the context of lectures for a course you're involved with, and discuss active learning in 4D in lectures. And so one thing I want to note here is this is a discussion. So at any point in time, feel free to raise your hand, jump in, type something in the chat, and we'll talk about it. I do have this largely structured in two portions. Part one is kind of the case study. We'll talk about what's 4D in active learning. We'll talk about the structures and how to incorporate active learning in 4D in lectures. And then in part two, we'll have some breakout discussions where you'll explore some of these ideas with our colleagues here today. So to set the context of where I'm coming from, I teach a course called Ecology and the Environment. It's team taught. The teaching team is variable per semester, but always includes me. We have 2 or 5 faculty per semester, about 275 students each semester, and it's a mix of majors and non-majors. About 20% ecology majors, 10% biology, 10% other STEM, and 60% from 30 plus majors across the university. And so we've got to thread that needle between the majors and the non-majors. We have 2 one-hour lectures per week and a 1 one-hour section, which takes the form of traditional kind of discussions or mini labs. And today we'll be highlighting the lectures. So to start off, if we're going to talk about 4D, we can ask ourselves, what is it? And you know what? As many people as I ask, I get a slightly different answer to this question. So I'm going to tell you how I think about it. When I look at these 4 concepts, or these 4 categories here in the framework, we have core ecological concepts that are arranged from organisms to the biosphere. This is basic ecology content. At number 4, we have cross-cutting themes, which I consider a little bit like content that is spread out oftentimes throughout the semester. And that's why it's cross-cutting, right? It can go with multiple concepts, and it also touches on these other 2. Ecological practices I see as really being about scientific literacy and the process of science. So things as simple as reading graphs or understanding science that students see in the news, or as complex as working through an experiment. But it's about doing ecology, the science of ecology. Human environment interactions spans a wide range of things. I mostly think about this in terms of the management side, as well as the critical thinking about ethical dimensions. And so I really feel like those work well in the form of discussions. And so for the rest of today, I'm going to boil these down into these 4 categories, right? I don't want to get into the nitty gritty of each of these, but rather consider them from a higher perspective. So we're talking about 4D. We're also talking about active learning today. And I think the easiest way to think about active learning is to contrast it with passive learning. So here's a picture of a lecture from 600 years ago with somebody standing at front on a stage and telling other people things. And it interestingly looks very much like most lectures that we see today. And so this is not what active learning is. Active learning involves students actively engaging with the material in the classroom. They're answering questions, they're talking to each other, they're doing things. And so let's have an active learning event really quick to start off. Why do you think it's beneficial for students to engage in active learning? Just think of something off the top of your head and enter a reason in the chat box. We'll give you just 20 seconds for this. We got deeper understanding, keep them interested, helps them pay attention, retention, makes it more applicable, critical thinking, ways to gauge their understanding, keep them awake, yeah, better learning. Great, we're all on the same page here. These are exactly the type of things that we can get from active learning. And there's data out there that shows this. It involves critical thinking. It encourages engagement, creates a personal connection to material, reinforces concepts and skills. And most importantly, this is all oriented about being engaged and learning more. And this is what we can do through active learning. And so in my course, we had a goal. And our goal was to add more active learning to the course. And we were in a really interesting position because we had learning objectives that were linked to 4D. It's an ecology course, it's a science course, and in our case, it's ecology and the environment. So we really wanted to engage in some of those more environmental science types learning objectives. And so we set out to do this. Before we talk about this, though, I want to give you a poll. Which of the 4 dimensions do you mostly closely associate with lecture content? So we've got a poll launched.
Yeah, I've got half the responses in now, Justin. Just give me 1 moment.
Yeah. Wait, we'll give it to about 20, 25. All right. And let's see what everybody said. All right. And that's about how I expected this to end up. 80% of you said core ecological concepts. And I think that's the case for most lectures. And in fact, in our course, I would say core ecological concepts were a lecture. And we were also doing a pretty good job of cross-cutting themes. And this is not to say we didn't touch on ecological practices. This is not to say we didn't talk about human-environment interactions. But they really weren't the major thrust of the lectures. And the last time I was at ESA, back when we were fortunate enough to have it in person, the annual meeting, I would talk to people about active learning, and they'd say, well, I do these things. I do ecological practices in my field course or in my labs, and I have human environment interactions in discussion sections. But what we really wanted to do was bring these into the lecture. And the way we thought we could do that was with active learning. Here's why. What are ecological practices other than practicing science, right? We can bring those into the lecture by having activities. And human environment interactions, we can have activities and discussions during our lecture. And so what we were really looking to do is take our lecture and make it look more like this, to cover all of 4D in lecture, not just concepts and cross-cutting themes. And if this is starting to look a little bit familiar to you, it's because we were exactly trying to make this symbol in our lectures, the unified 4D figure. And so this is a little bit of a case study. So I'm going to tell you about where we are now and how we got there. And so the key thing that I want to stress here is that we moved incrementally. We did not jump into this and suddenly transform our entire course. And I'm going to show you some data here that's been a little bit de-identified because I can't fully share it all outside of the university, but I just want to show you the general trends. In this case, we started off with very little active learning in our lecture as measured by a Copus report, which basically is like an ethogram. It measures how much time students are spending engaged in active learning. We started in the past with very little, and over time, we increased active learning to the point where about students being engaged in active learning about 50% of time in any given lecture. And as we did this, students identified active learning as being more helpful for them. They felt they learned best with active learning. They thought class time was used better, and they felt the course was challenging them intellectually at an increasing rate. And we also had measurable positive outcomes. As we increased the amount of active learning, we had a student confidence survey we gave before at the start and end of the semester. Students' confidence was increasing much more when we use more active learning. Their confidence with science, their ability to understand things in the news and so on. And their score on a pre and post concept check was increasing over time as well. So we know active learning improves student outcomes, and that's been demonstrated a lot of times before. But how did we integrate 4D and active learning in the course at the same time? And I'm going to concentrate here on 3 specific aspects of the course: a pre-lecture reading assignment, our active learning lectures, and our post-lecture quiz. For each lecture, students take a pre-lecture reading quiz that is lower level Bloom's. And in the chat box, I'd like you to take a moment and tell me, what do you think a benefit is to having students take a pre-class reading quiz in their course? So first idea off the top of your head, 20 seconds. I see accountability, gives you a baseline, engagement. They'll read the chapter, yep. You know where they're coming from. It's an incentive to read. Make sure you have a reading baseline. Yes, and these are all the types of things that I'm thinking about. When students are you take a pre-lecture reading quiz, they're held accountable for the reading. Students have learned something. They come to class with a basic understanding. And most importantly, it frees up class time for active learning in this context. A pre-lecture reading quiz that's lower level Bloom's means everybody comes to the class knowing the basic definitions, for example. And so we don't have to spend time covering those. We can dive into the active learning. And so then students would attend the lecture, and we'll cover active learning in lecture in a second. And we also have students work on a post-lecture quiz that's higher level Bloom's questions, more engaging. After the active lecture, they should know more to engage in those higher level concepts. And this is for every single lecture. Yes, I see Bruce asked the questions there. Every single time they do this for every lecture in the semester. Now let's take a moment to concentrate on the active lectures. And our philosophy behind these is lectures should be interactive stories that are relevant to students' lives. Students should be a part of a community that works together. And maybe most importantly, we only award participation points. This allows us room for creativity and a positive learning environment, And many of our questions have no answers. We don't want students no correct answers. We don't want students stressing about these things. We want them to be able to engage meaningfully. In practice, we use a student response system such as Poll Everywhere or iClickers. We have a microphone in the course. There are 5 to 12 active events per lecture, and activities range in time from 1 minute to 10 minutes in duration. And almost every single activity involves students talking to each other prior to answering. And so our course is set up very specifically where students sit in a region of the room near their TAs. This means they know somebody sitting near them, and so they're more likely to participate. The TAs stand up and walk around during active events to shift the tone in the room. This helps students ask more questions, and students are held accountable by their TAs. When students are participating, the TAs can engage them. And so the advantage of this was increased student engagement. Simply by having students sit near their comrades, their colleagues, engagement in our course went from 75% to 90% over a semester. And next semester, we'll start using heterogeneous teams of 4 students each at group by section. How many TAs do we have? We have 1 TA per 50 students or thereabout. Now what I'd like to do is to show you some examples of active learning. And I actually prepared this slide deck for a different presentation and that didn't involve 4D. And what I'm going to do is I'm going to show you some examples of our activities and identify which dimensions I think they hit on. All right. So the heterogeneous teams, somebody asked a question. Those are based on familiarity with science and ecology. So the teams will be based on having, an ecology major with a non-major and in between. And so here's an example of something that I think touches on concepts and human-environment interactions. Discuss with your neighbor. Is Smokey the Bear a hero or a villain? Here's a great one that I think really touches on 3 aspects. We have students actually decide how many cattle they're going to graze on land. They're really engaging in the tragedy of the commons. And then we ask them, can the tragedy of the commons be overcome with regard to global warming? We've hit on multiple dimensions there. Here is one where students are asked to graph the population growth as a function of time and then indicate the level of competition on the graph. And so it's touching on concepts, it's making them graph, and so it's also number 2. Here are some example worksheets that we might use as an activity. Here is from our diversity lecture. Students actually collect data on the beetles. They then calculate the Shannon Diversity Index and make rank abundance curves. And lastly, they have to decide based on alpha, beta, and gamma diversity, which region they would protect. So they're getting content, they're working on a simulation, collecting data, doing an analysis, and then answering a management question. Here's one that looks at the Whittaker diagram, and students have to interpret climatographs and where they would fall in the Whittaker diagram. So they're covering content, and they're really diving into graphing because these climatographs are somewhat complex. Here's some activities that students have done. For example, working with this heat balance model by having to survive on a desert island. They apply this to themselves and then later on to animals and plants. We've got one here about transmission of a virus. We watch a virus spread around a classroom, and then later students had drawn cards on the way into the room. A certain proportion of them are vaccinated, and we look at how we've lowered R naught such that the disease is no longer spreading in the classroom simulation. Biogeography, throwing candy at students, and certain patches of them are islands. We were able to basically recreate island biogeography in this manner. This one I wouldn't do again. It took too long for one learning objective, but it was certainly fun. And we've got other examples here as well. And so the key is that what we're doing is we're bringing in the ecological practices and the human dimensions into our lecture content and making it a full 4D experience. And people always ask how we develop activities. And the big questions I get are, how long will this take? How long will it take to prep for? Will it work? And the question I get most frequently is, how much do I need to cut? As far as will it, I'll talk about these two in a moment, but will it work? The answer is sometimes. We've tried things that haven't worked, and we're always improving what we do. But as far as how much content needs to be cut, I have another poll here. If we add a 3-minute activity to a lecture, how many minutes of other material would need to be removed from the lecture? And so I'll give you 20 seconds to answer this, if that. All right. And can we show the answers, please? Okay. And most people have said less than 3 minutes. And that is what I think is the correct answer. A lot of times people think that if you add an activity, you just have to cut an equal amount of things out. And so for a giving learning objective, a traditional lecture time might be 5 minutes. And we're going to add a 3-minute activity. But we're going to get at the same learning objectives in a different way. We're not going to just tack on a 3-minute activity to what we have. We're going to integrate 4D in some way that achieves the same learning objectives, so the amount that we add is actually a bit less than 3 minutes. We will have to cut back. We will have to cut some, but it's not nearly as much as might be anticipated. And so the way we go about this is we look at a lecture. This is a slide deck. We identify places where we think we could add activities. We then go ahead and add them. So here's a lecture that started with none. We added 3. And after 2 semesters, these green lines represent the active slides in the lecture. Likewise, here's one we started with 1. Then we had about 4. And after several semesters, you can see we have a great deal of activities in there. And so the examples I showed you were very formalized. And one thing I'd like to point out is that I think that it's in a huge lecture with many students, you almost really need to have them formalized. But when I was teaching at the community college, you know, I would have classes with 25, and I would just do a lot of this on the fly. And so it wouldn't necessarily take that much prep. If I had a good idea, I would just have a small note in my lecture notes, and we would just do it. With that, I think I'll take a break for questions. I see a few questions popping up, both people with hands raised and questions in the chat. I see Sean has a question.
Yeah, hey, thanks, man. This is great. So I just was wondering, on your previous slide, were you talking about, like, so you had the outline of your lecture and those different slides? Yeah, right. So does the green mean you bailed on that, or does the green mean you supplanted that with slides that were directed at the active activity?
Yeah, and so what I'm saying here is that this was the lecture, and this right here is where we insert an activity where we have green. And so I guess the point of these couple figures here is to basically point out that we ended up someplace with a ton of active learning. But we just started with a little bit. We got our feet wet. We learned as we went. We didn't just jump into doing tons of this at once. We built each of these over the semester, and that made it manageable to get done.
Cool. No, I totally agree. And I think that I like this way to visualize it. Thank you so much.
Yeah. And as a note, one of the reasons that it's visualized this way is all of the activities in the lecture are called out with a colored slide, so that students recognize that it's time to be active, so that they know that they have to be up and moving and talking. Yeah. Other questions? Can we go back? Oh, that was Sean's question. Other questions? All right. So now we are going to go into discussion groups so that you can kind of think about these things with your colleagues. We'll use breakout rooms. We'll have 2 discussions. One of them is to generally think about how you might integrate 4D into your lectures of your course. And so I've given you one example, but there's a million ways that I think we could come up to implement active learning and 4D into lectures. So what might work for you as an individual will be our first discussion. And in this discussion, we're going to paste a link in the chat, and you can open up, you can go to your breakout room, and as a group, claim a slide to take some notes. This is Scramble competition. Do not delete other people's typing. Just claim a slide and keep it as your own. It is not interference competition. Discuss your idea and take notes. And I think I'll give about 10 minutes for this one, and then we'll come back and see if anybody has anything we can discuss as a group, and then do our second breakout room. All right, well, welcome back, everybody. I hope you had some interesting discussions at the interface of active learning and 4D in relation to lectures. Does anybody have any general thoughts, ideas, or comments about either of the prompts? Just generally how you might implement this across a semester, or any specific examples? Feel free to jump in. All right, well, I'm going to look at what you
I'll say one thing we talked a little bit about is the idea of doing more data analysis and pulling more as a, I think a lot of us are already trying, like, hey, what do you think about, or what's your opinion of, but to actually have them do a bit more like quick graphing or interpret graphs, that kind of stuff.
Yeah, that's one of my favorite things. Tons of our activities are making graphical predictions before we show them a trend, like how might the amount of light relate to the amount of photosynthesis, right? And you give them a graph space and have them make that graphical prediction. And I mean, that's a really strong way to get at graphing skills as well as some science skills and content. Yeah, other thoughts? Looks like somebody's, no. All right, I'm just gonna read some comments off of the pages you guys filled out and see if I can identify any themes. We've got a group here that talk about reading a scientific paper. Each one reads a paper and then gives a mini presentation on it. Yeah, that could be a great way of active learning. You know, they do something, they make a small presentation, and you spread out the learning. We've got a list of things: in-class polls, discussion, group problem solving, ecological application questions, jam boards. Yeah, all sorts of things. And I think that brings up a really big point. And that's that, you know, I've talked to a lot of people who do this, and they say, you know, I do this. I have 5 multiple choice questions at the start of every lecture. And, you know, and I know a lot of people do that, but our philosophy was that didn't work as well as kind of incorporating these things throughout the lecture. And then we also gave ourselves the freedom to do whatever, whether it's a worksheet, an activity, a simulation. And so we tried to vary it as much as possible. And I think the key to that was that no matter what it is, even if it's just a multiple choice questions, the students always work in groups and discuss their answer before actually answering. So even with eye clickers, we're getting some dynamic interactions there. Let's see. Some type of product, structured group worksheet or activity. Yeah, and that brings up a good point about structuring. And I don't remember if I answered this or not, but in the large lecture, these really needed to be structured. It's really tough, even with, you know, one TA for 50 students, to keep on top of everybody. And so in my small classes, I was able to do it on the fly and answer questions and do things. But in a larger class, these really have to be well-defined and structured. So for instance, what we did here today, I wouldn't do it the same way again. I would probably modify it because I saw some problems and it wasn't effective. And that's what happened with our process. We would try something and we'd be like, oh, if we just tweak it, if we make this instruction clearer, we give more or less time. And so I mentioned before about adding all these activities to the lectures, but what we were really doing, you know, we added one, we would tweak that one the second time around and add more to that lecture. Let's see. I see another one about polling software. And you mentioned data analysis. Other thoughts?
Are you asking for us right now?
Yeah, anything you'd like to contribute to the discussion. We're kind of wide open.
So are you familiar with team-based learning?
Yes. And in fact, I talked about that regional seating. Next year, we're going to teams of 4 students. And those teams will be based on a level of experience with science and ecology to get heterogeneous teams.
I had an incredibly, well, first time I taught it, you know, they all complain it's bad, but the second, so I didn't do it for a year. And then last spring I did it in my wetlands class and it was absolutely phenomenal. It was like textbook perfect. And when we went to online, we just did those teams. We, you know, they had prompts, or they would work on these quizzes. When you mentioned that beginning of the class quiz, the IRATs and the GRATs or whatever, those were so helpful. It really helped the students learn and be able to apply some of these tricky questions in terms of wetlands ecology and biochemistry and stuff. I thought it was very successful. So that's just another potential approach.
Yeah, since you brought up online learning, I should mention, you know, so we also did active learning in our asynchronous online class. We had recorded lectures, and they couldn't interact with other students, but the lectures would pause and have the same interactions we would have had in lecture, plus some that we added. And so we were still able to maintain a form of active learning even when we were online. And when we were online, we also do have teams in section all the time. We haven't been able to implement them in lecture until I finally convinced the university we needed a bigger room. And so now we're going to be able to effectively do that. Other thoughts? I think, Jessica, you said you needed, if nobody else has anything else, you needed a moment to wrap up.
Yeah, just a quick second. That's more or less, I guess, because we're at the top of the hour. I do see a question in the chat that says, will the slides from today be available to view? Justin, do you mind sharing the slides, or? Yeah,
well, there's some data that's hidden that I can unhide, and I also might clean them up a little bit, but yeah, I can share them after the fact.
Okay, we'll probably create a water cooler web page for this event, and just kind of compile some of the information, share your slides. But I really just wanted to take the opportunity to thank everybody for their participation. If we want to have like a couple more minutes, I'm happy to stay on for a little extra time, maybe 10 more minutes. And I did want to tell everybody that we have the upcoming water cooler chat. One more, it's the last of our spring series, kind of running into summer here a little bit, but that's going to be on June 4th, and that's bringing 4DEE to TIE. So that's an acronym crazy title there, but TIE is teaching issues in experiments in ecology. So it's peer-reviewed teaching resources, and we're going to kind of try to do a little bit of what we did here today, but we're going to take an existing resource and try to turn it into a 4DE TIE resource. So I'm going to stop sharing screen. If there's some more comments or lingering comments, you're welcome to do that. But if you need to pop off, this is a thank you, and I hope everybody has a great weekend. And great job, Justin.
If anybody wants to discuss anything further.
I'll just say thanks to you. This has been great. I'll just say one thing that we were talking about a bit is what things were we going to, I think a lot of us felt that this forced us to be online, and many of us had to, by definition, become more comfortable with these tools. And then a lot of us are anxious to get back to the face-to-face, but there's some things that are going to be very sticky, and there's some things that we're not going to leave. And Bruce said, for example, he wants to keep some of the online elements, but do that with, say, laptops or whatever inside the room. So instead of like a week-long exercise, like do it inside. And I was just curious what people were thinking in broad strokes in terms of things that they think they're going to keep going, or what elements of this online life is going to keep going even if you're not in an online class per se.
Yeah, I can speak for us, is that, you know, we had a lot of section activities and things like that where we had students do a lot more prep, because suddenly we said, oh, you know, it's so hard to get in the breakout rooms in and out. We lost all this time. And we had students do more prep, and we looked at it, we said, why were we doing this ahead of time, right? Like, having students do more prep, that can't be bad. And so, you know, that's a great example of that type of thing that we're going to keep going. And we, you know, we also, so in our digital lectures, we recorded them with our traditional activities, and then I would retroactively go back in and sneak in new activities into places where there were big gaps. Our goal was to have an activity at least every 5 minutes. And I think we're going to keep a bunch of those that they maybe ended up being better than what we were already doing. And I totally agree. I think there's numerous ways that we can take what we've learned here and bring it back to our face-to-face courses again. Anybody else have any ideas about that?
Well, not about that. I have a question in a different domain. And again, I mentioned this, and many of you know me. I was not involved in the 4DE. I was very much involved in TIE and other things. But I'm wondering what was the decision about? What was the discourse about why ethical dimensions was not a cross-cutting theme? Why is that in 3 and not 4?
That's above my pay grade. That's an Alan question right there, if I ever did hear one. Alan, you got any thoughts on that?
So I think actually, Bruce, that the 3D NGSS world is actually really struggling with, well, not really struggling. My chums in that world are having fun struggling with actually kind of, they don't have a fourth dimension. They don't have a human environment, right? But they're struggling with what should be a cross-cutting theme versus a practice. So for instance, is systems thinking a practice kind of part of modeling, for instance, or is it a cross-cutting theme? And I think what we realize is that if you're thinking about integration, then it lets you off the hook a little bit, because you say, well, it's kind of both. That's kind of what makes it a cross-cutting. So we haven't really kind of operationalized the practices in terms of how they really do interact with the concepts. So you're saying that there's a kind of a values thinking practice.
There's a 5th dimension called cross-cutting practices.
Cross-cutting practices. Well, that could be a way to think about it. Yeah. No, it's a temptation to make the human environment interactions all kind of cognitive, concept-y type things, right? And so that's and maybe the ethics literacy, which is what I think of as that 4th element of the human environment interaction dimension, is a more active and practice-like. But you're actually arguing that it's a cross-cutting,
right?
But we want them all to be cross-cutting, Bruce. So you don't want to.
Some are more cross-cutting than others. So there's 100 years of literature on critical pedagogy. It wasn't called that until the late 60s and 70s, but that's what that one's about, critical pedagogy. Whatever we teach, we also should teach what that knowledge is for.
Yeah, and I think one of the, like just in the conversation we just had with Gustavo and the breakout group that I was in, to me, the first step in really bringing 4DE into teaching is to identify a purposeful issue or question that you really want to answer. And almost anyone worth its salt demands 4 dimensions, right? So and including an ethical and what you're arguing, kind of a critical dimension that kind of, which is kind of answering the question, what is this for? Why do we want to understand native, or exotic species in my schoolyard, or Lyme disease, or the ecological basis of coronavirus, right? And as soon as there's an ethical dimension to that, and there's all the other dimensions are there, right? You need practices, you need big ideas from cross-cutting, you need concepts from all the, so that's, but I think you're arguing for kind of grounding it in a purpose And I agree.
Fifth
Right.
dimension.
No, that's an interesting, I'll have to think about that more. Yeah.
So maybe, Alan, this is a good time to perhaps say that ESA is interested, or the subcommittee, the 40E subcommittee is interested in diving deeper into exactly questions like this, right? Like,
Yeah.
what does it really mean? All these
Right.
words, terms and
Right.
categories, and what does it really look like? And so these are excellent questions. We don't have all the answers either. We just knew that we had to go beyond just that one category of ecological core concepts, but and we know that this is going to be a work in progress. So all these sessions with your questions, with your participation is really, really important for us. So thank you. Yeah.
And I would say, from having been talking with people about this a lot more, everybody has a different take on it. Like, you know what I mean? It was really hard for me to define because, it's the way I interact with it and how I do it. And for me, it's about finding those lecture items, like I mentioned, where I can take a concept and bring in items 2 or 3 to make it more robust and better coverage. And so, I think if it's even just doing that, even if we're just thinking about it this way, it's doing its job to some extent, right? Even if it's not a perfect framework, if we can use it to expand, then it's a win.
Yeah, it's cool.
Yeah.
Shall we wrap this up?
Yeah, I was
Great.
gonna say.
Thank you, Justin. This is
Thank
Yeah.
you, Justin.
Thanks,
really
everybody.
great.
Thank
And
you
thanks a
very
lot,
much.
Sean, for speaking up. You saved
Thank
me.
you, everyone. Bye.